Today we're going to be dealing with 11.4 three-dimensional figures, and so this is in our student journal on page 331. Alright, and you'll notice on that page when you get there, it's just a bunch of vocab terms. So as we're going through today's lesson, if you read through these terms right now and you go, man, that's one that I don't know, then it'll be something to listen for, and then you can define them at the end of the lesson there. Okay. It also has some space on the bottom for notes, and down there on the bottom, that's where I want you to just put some notes about the stuff that's on this page here. So I want you to work with your partner, read through this start thinking, and then explain the answer to their question there. Okay? Then just a couple minutes on it. So for those of you that are trying to figure out a way to organize this, it might just be nice to make a table. So if you have a triangular polyhedron, a rectangular polyhedron, a penta, and a hex. And for each of those things, you're being asked faces, vertices, and edges. A good way to kind of organize that. Okay, hey, they define a lot of things in here, right? A lot of those vocab terms, the polyhedron. You didn't know what it was? Dude, they tell you right away. A polyhedron is solid that's bounded by polygons. Okay? Called faces. So, like this has a rectangular prism, has a bunch of rectangles. Okay? Or quadrilaterals. Those are the faces. The faces intersect to form segments called edges. When three or more edges intersect, they form a point called a vertex. So a lot of these things that are on this page are defined right here. Okay? This is not on a page. Okay? But page 331 is where you have all those vocab terms, right? Okay, so a triangular prism, how many faces does it have? I hear 5 and 4. 1, 2, so we got 5. Okay. How many vertices?
6. I said 6.
Edges? I'm just writing what you guys are saying. So what do we have for edges? 9? Okay. Okay. Let's go on to rectangular. Tell your neighbor what you got for that one. 6. Okay, rectangular. What do we get? 6 and 8 and 12, okay? Penta, what do we have?
7, 10.
15, okay? Hex?
8, 12.
Okay. F plus V minus E. That'd be our last column. How do they relate? Monty? Okay, yeah, these always differ by, like, okay, so if you're relating V and E, hey, this is hexagon, it has 6 sides. These are always 6 apart. It's 5 sides, 5 apart, 4 apart. Good, that's a good deal. That's a good observation. Sam? Okay. Do you know?
It's all of the answers always equal to.
Okay. All right. Good. So it's always 2. So Sam, what you said there is actually that as well. So when we add F plus V and subtract E, we get 2 every time. Yeah.
The F is the number of sides, like in the normal, say triangle, rectangle, plus 2. The vertices is that times 2, and the edges is that times 2.
Good. Yeah. So you could also relate these things to, if we called this N, meaning the number of sides, where this would be 3 for a triangle, the number of sides in a base. Okay, 3, that would be 4, 5, and 6. There are a lot of different patterns you could look at. Okay, what Danica said there, that's F or excuse me, f is equal to n plus 2. Okay, here it's n or 3n. Excuse me, not 3n, 2n. And e is, yeah, it's 3n. Okay, so those are all different little patterns that we have. Okay? Okay. Is this a polygon? Tell your neighbor yes, no, why not? Good. So Alex, what'd you say? Yeah, it's a closed figure with straight edges, distinct sides. Okay? Is this a polygon? No. It doesn't have straight edges. It has curved sides. It's curved. Is this a polygon? No, this is a polyhedron. Okay, polygons are how many dimensions? 2, whereas a polyhedron is 3. Okay? Note the difference there. All right, very good. So, using that, let's go ahead and take a look at page 332 or 322 of our text, or of our student journal here. Types of solids. All right, so these polyhedra, non-polyhedra. Tell your neighbor why these are not polyhedra, whereas these are polyhedrons. Okay. KJ, what do you think? Why are these polyhedron and these aren't? Yeah, these are all curved. Yeah. So that's the difference there. These have curved edges. These are straight. Okay? Not terribly difficult there. All right. I want you to answer questions 1 and 2 on your own there. Page 332. All right. Hey, Nathan, yes or no on this one? Yes. Okay. Jeremiah, yes or no? No. Okay, if it is, name the polyhedra. Any idea? Yeah. Okay. Yeah? Okay. Okay. Okay, so I hear what'd you say, Muncie? Okay. I heard tri, were you thinking because of the triangular face? Okay. And I hear octa. Why are we saying octa? 8 faces. Yes, this is actually called an octahedron. Now on the back wall there, like if you look above, there's some like pretty cool polyhedras. All right. I know that Mr. Allenson at the high school, if you guys know Kenzie, her dad, he loves, like he digs this stuff. He'll build them and do all kinds of cool stuff, or used to. Okay, so if you ever get Allenson as a teacher, it'll be a fun one for you. Okay? I don't build them. I'm sorry. I wish I could. That'd be really cool. Okay? All right. I probably could if I put some time there. All right. Why don't you take a look at the next page, 333. I'm not even going to explain 1 through 6, or 3 through 6. I just want you to read the directions and do the best you can there. There's some vocab that you may not know, but we'll talk about what that means here in a minute if you're not sure. Try to use the context.
Wait, what's Jason Voorhees' favorite dessert?
What?
Ice cream.
Ice cream. Gee. Let me see Gino on stage. Stand up on the kid.
Exactly.
Good job, Gino. All right, number 3. Describe the cross-section. Notice cross-section. When you take a plane and slide it through and you chop a polyhedra or a prism or something, in this case you've got your pyramid or your hexagonal prism. Is that hexagonal? No. That's hepta. That's 7 sides, okay? Hey, what do you form right here when this plane slides through it? What's this shape? It is a rectangle, yes. And if we knew that these lines were parallel, we could actually call it a square. We don't quite know that, but, okay? Yes, this is a rectangle. Could be a square. Actually, technically, it would be a parallel. But we're going to assume that these are parallel. So I'm going to call it a special rectangle, which we're going to call a square. Okay? You should have more markings there, but that's okay. You got your quadrilateral there. What do you have here? Yeah, you have triangle. All caps, see? That's an intense triangle. Okay? How about this one? Yeah, you get a trapezoid. Parallel sides. And the next one you get a heptagon. Hepta meaning 7. All right. Last piece. In exercises 7 and 8, sketch the solid produced by rotating the figure around the given axis. So in other words, if I were to take this figure that's on this axis and I were to swing it around, what three-dimensional shape would it make? For like number 8 here, this is actually, let's use number 7. This would be, now I'm not promoting gambling. They're just ones that gave us free cards. Okay, this would be the situation. Here's this shape, just like that one. Here's your axis, that pencil. I want to know what three-dimensional shape would be swept out if I rotate it. Like that. Okay, or you look at it like this. I don't know how well you can see that. But you're rotating that shape. What three-dimensional shape would be swept out? And the same thing with this one. Okay, there's the same shape. You're rotating it. So what three-dimensional shape? Okay, if I were to swing it around like this, what shape am I sweeping out? Very hard to do this so you guys can still see it. Okay? What three-dimensional shape is that making by rotating it around an axis? Try to draw it. Hey, let me help you through the first one here. If I swing that around, it's obviously going to sweep out a shape over here as well, about the same. It's going to mirror it, right? Now that would be the two-dimensional figure of it. The three-dimensional figure, it would kind of have a circular top because we're rotating around a circle around the axis. And the base here would also have a circle. So actually I should probably dash this. Makes it a little easier to see. Okay, and so rather than it being a straight edge here, it would be curved because it's rotating around. So your figure, and this would be, actually that would be solid. Okay, so if I were to redraw this, there and there are the two sides, swept out. If I draw straight lines, that's the two-dimensional. If I want 3D, just round these off. There's my three-dimensional shape by rotating it around. I think the same idea over here, it's just a little different on one of those sides there. Draw the 2D first.
Is drawing this going to be on the test?
It might be.
Oh, God.
Jeez, that question, is this going to be on the test? What a teacher hears when a student says that is, do I need to learn this? That's what I hear.
Shapes are actually the worst.
Come on, man.
Well, that's what we're trying to say. It's just a nicer way of saying it.
Yeah. So yes, you should learn. I know.
Well, do you want to start from the beginning?
No, you don't get.
Draw the 2D first. How many have drawn the 2D? The 2D. You just replicate it, which sometimes is more difficult than it looks, obviously, because I can't draw it. All right.
Wow, the triangle.
So if we replicate it, there's the 2 dimensions. Now, what will the top look like? Will it be solid? Will it be open?
I'm thinking solid.
It'll be solid, yeah. What will the bottom look like?
I'm thinking open.
What's that? Yeah, the bottom's going to be a big circle. Okay? The top has that point. So the bottom here, you would have this circular thing going around the axis. Kind of like so. So if you're actually drawing this in a way that is a little easier to look at versus what I just had there. What's that?
I don't know what that is.
Do some what? Sorry, this would have to be rounded. I don't know what you're talking about.
You know.
Total shading? Oh, tonal. Sorry, I thought you were like going totally 80s.
Bet somebody would pay like $6 million for that. Just 'cause
Probably.
Abstract. Should it be like a line in the middle?
Make sure that you label the measurements they give you. 4 centimeters would be there. 8 centimeters here. 2 centimeters here. Okay, and on this one over here, still label it. So for those of you who take design classes, this would be some of the 3-dimensional design. Many times, which you're actually doing this on computer, it's good to be able to sketch out first. Okay, this kind of got punched in right there. I don't know. Yeah. Cool, man.